Hello, everybody. This is the lesson video for writing and interpreting algebraic expressions. Today, really what we're looking at are these first two learning targets. On Thursday, we'll be looking at the last two. But today, what we're really thinking about is writing expressions that record operations with numbers and letters standing for numbers. And we will be identifying parts of an expression using mathematical terms. We'll view a part of the expression as a single entity. So looking at our start problem here, I want you to kind of observe what you're seeing. What operations am I using? What numbers are present? What does it add up to? So just like we would in class, we can see here we have some addition. We have a little bit of multiplication going on here. I also see that I have some 2's in most problems, and then 4 in some. Okay. But really, what I want you to think about is the relationship between addition and multiplication. So, in looking at this first one, 2 plus 2 plus 2, isn't that the same as 2 times 1, 2, 3, 4? We would get the same thing, right? Because multiplication is the same thing as repeated addition. So, if I know that 2 plus 2 plus 2 plus 2 is 2 4 times, right? Can't we say that this one is the same? Same thing happening here. And then looking at these, we can group these together to be 4 plus 4. And that looks very similar to this. Okay. Or we can think about doing 2 times, 2 times, which looks a lot like this one. So in the end, they all have the same result. We're just looking at how we can express or use operations to make it happen. Okay. Looking at number 1, the Ramirez family is making tamales. They wrap the tamales in corn husks for baking. And this one, I'm just going to cross out there for you. We actually steam tamales for steaming. They have 8 corn husks. Isabel is bringing 3 bags of corn husks. Each bag has the same number of corn husks. How can you use an algebraic expression to show the total number of corn husks the Ramirez family will have after Isabel arrives? So if we were learning in person, I would use algebra tiles to help demonstrate this. But since we don't have manipulatives that we can use on hand, we're going to draw some pictures to model this. So we know that they already have 8 corn husks. So I'm going to start by displaying 8, starting with 2. Then we have 4. And then we can cut those in half, and then we will end up with 8. Okay. Then it says that Isabel is going to bring 3 bags of corn husks. Okay. And the bags are going to have the same number of corn husks. We just don't know how many that is. So whenever we don't have a number ready to put in, we're not quite sure, we can always go ahead and put in our variable. And a variable is a letter we're just using to represent a number that we're going to put later. Okay. So now I can clearly see how I'm going to write my expression. I have 8 plus how many bags of husks? 3 bags of however many husks they end up having. Okay. Now looking at number 2, it's going to ask us for 3 things. So I'm just going to write this down here. An algebraic expression will have a variable. There will be coefficients. And the last thing is a term. Okay, so in this problem here, it says that Gaspar writes the algebraic expression 5b plus $3.79. This expression represents the total cost in dollars of buying 5 bagels and a container of cream cheese. So what we're going to do is we're going to look for those things here, a variable, a coefficient, and a term. So we talked about in the last problem was what a variable is. That's something that we don't quite know yet. We do know, however, that this 5 represents how many bagels he has eaten, but we don't know how much it costs for the bagels. So this one here is our variable. So we can find out later that a bagel is $2 or it's $1.50. Then we would put that in place of the b. So that one is our variable. Okay. A coefficient is just a number. It's representing a number. It's usually connected with your variable. So our coefficient in this case is the bagels. How many bagels is he buying? He's buying 5, and then we're going to multiply it times the cost. Okay. And that leaves terms. Terms are individual parts of the expression. So let me see here. I don't want yellow. Let me get a different color pen here. Okay. For a term, we're looking at the different parts. So here's one part, that's a term. And right here is a term, because 5b represents the whole bagel situation, right? How many I have and how much they cost. Then we know the other part is a term because it's just the container of cream cheese. Okay. Now looking at number 3, we're going to write an algebraic expression. It says the product of 5.8 and the sum of 9 and a number n. Okay, then it wants to know which expression is a sum of 2 terms. So first of all, let's just get started with writing the expression. So it says the product of. So product, I know, is going to have to do with multiplication. And sum, I know, is going to have to do with addition. So it says the product of 5.8, and I'm going to multiply it by something. The sum, so I'm going to add 2 things together here, of 9 and a number n. Okay. Now it asks, what is a sum of 2 terms? Well, where in our expression is there addition happening? Where is there a sum? That would be the sum of 2 terms. Okay. In part B, an algebraic expression for the word, we're going to write it for the phrase below. Subtract a number. So subtract a number and then divide. So just looking at this expression, I know that I'm going to be using 2 operations when I'm writing my expression. Okay. So subtract a number x from 15. Then divide it by 2. That's one way to write it, because this division symbol here is represented by a fraction bar. Or the other way we can say it is subtract a number. We don't know the number, so we're going to put x from 15, then divide by 2. Okay? You don't actually need those parentheses, but actually, yeah, let's go ahead and put those in, because then we can follow the order of operations there. Okay, so either one of those is fine. Now looking at number 4, Lorena has a $50 gift card. So I'm going to model this one with a tape diagram. So here's Lorena's gift card, right? It says it's worth $50. There's her gift card. For an online music store, each song costs S dollars. So we don't know how much the songs cost yet. Write an algebraic expression that represents the amount left on the card after Lorena buys 7 songs. So the amount left, I'm thinking about that already, thinking this may need to be using operation subtraction, right? So let's see. So it says she's going to buy 7 songs. So I'm just going to go 1, 2, 3, 4, 5, 6, 7. That's how many songs she has purchased. Now I see this is how much left over. Okay, so I can clearly see I'm starting with 50, right? I'm starting with $50. Right? And I've bought how many songs? So how many am I going to take out of this gift card? 1, 2, 3, 4, 5, 6, 7, right? And we're going to show that it's 7S because we're not quite sure how much money she's spending on each of those songs. So that is how we would write our expression. Okay. Very good, guys. Remember to model math. Modeling math helps you so much more, I'm telling you. If you get stumped, Say it again to yourself. Look for those things that will help you. Look for operators, like what am I going to be using here? Am I using multiplication, addition, and so forth? Draw yourself a picture and write your expression.